Have you ever looked up at the night sky and wondered where it all ends? Not just the stars you can see, but our own cosmic neighborhood. Where is the final frontier of our solar system? This is a question that has captivated humanity for generations. It's a question that drives scientists and engineers to build incredible machines. These machines are designed to travel farther and faster than anything before them. They are our eyes and ears in the vast, silent darkness that stretches out beyond the planets we know and love. So how do scientists actually define this invisible edge? It all comes down to the sun. Our star is constantly blowing a powerful stream of charged particles out into space in all directions. This solar wind creates a massive magnetic bubble that surrounds our sun and all its planets. Think of it as our solar system's protective shield, a cocoon that travels with us as we journey through the Milky Way galaxy. The edge of our solar system, then, is the place where the solar wind finally runs out of puff. At the same time, it pushes against the particles and radiation from other stars in our galaxy. The boundary where the solar wind's outward push is finally balanced and overcome by the inward press of interstellar space is called the heliopause. Crossing the heliopause means you have officially left the heliosphere and entered the vast ocean of interstellar space. Launched in 1977, these twin spacecraft were sent on a grand tour of the outer planets. Their primary mission was to study Jupiter, Saturn, Uranus, and Neptune up close. For decades, they traveled through the cold, empty void beyond Neptune, flying silently toward the edge of the heliosphere. They were our lonely sentinels, reporting back on the conditions in this uncharted territory. Then, in 2012, something incredible happened. After a journey of 35 years and traveling more than 18 billion kilometers from home, Voyager 1 detected a sudden and dramatic change. It had punched through the sun's protective bubble and was now flying through the space between the stars. Its twin, Voyager 2, followed a different path and crossed the boundary in a different location in 2018. If you journey past the grand orbit of Neptune, the last of the gas giants, you enter a realm of profound cold and darkness. This is the Kuiper belt. It's not an empty void, but a vast, donut-shaped region teeming with countless icy bodies. These objects, known as Kuiper belt objects, or KBOs, are cosmic fossils. They are frozen in time, perfectly preserving the chemical soup from which the planets themselves were born. Here, we found Pluto, not as a lonely misfit, but as the proud king of a whole new class of dwarf planets. The New Horizons mission peeled back the darkness, revealing towering ice mountains and flowing nitrogen glaciers. The dwarf planets of the Kuiper belt are fascinating, complex worlds in their own right, with their own geology, atmospheres, and even moons. The lonely journey of New Horizons continues today, as it travels ever deeper into this icy wilderness. Beyond the Kuiper belt, beyond even the reach of our most powerful probes, lies the final and most mysterious frontier of our solar system. This is the Oort cloud. It is not a belt or a disk, but a colossal spherical shell of icy debris that is believed to envelop our entire solar system like a giant ghostly bubble. Its scale is almost impossible to comprehend. While the Kuiper belt ends around 50 AU from the sun, the Oort cloud is thought to begin thousands of AU away. It may extend outwards for nearly a light year, a quarter of the distance to the nearest star. The Oort cloud is, in essence, the solar system's grand nursery for long-period comets. As one of these icy wanderers finally approaches the inner solar system, the sun's warmth begins to work its magic. The pressure from the solar wind then pushes this material away from the comet, forming the spectacular tails that can stretch for millions of kilometers across the sky. These comets are messengers from the Oort cloud, giving us a fleeting glimpse into this mysterious and inaccessible region of space. In August of 2012, the moment finally arrived. After a journey of 35 years, Voyager 1 sent back data that made scientists jump out of their seats. For the first time, a human-made object was soaring through the medium between the stars. The data it sent back was revolutionary. It gave us our first direct measurements of the interstellar medium. Today, both Voyager 1 and 2 continue their journey into the interstellar void, still sending back precious data from beyond the edge. One of the most significant changes was the dramatic increase in galactic cosmic rays. Another key discovery was related to the galactic magnetic field. The galaxy itself is threaded with a weak but vast magnetic field. This new environment is far from static. The interstellar medium is a turbulent place, with shockwaves from distant stellar explosions rippling through it like tsunamis. These cosmic tremors are a constant feature of the galactic weather, a reminder of the dynamic and sometimes violent nature of the space between stars. Scientists and engineers are already dreaming up the next generation of interstellar explorers. One concept is a mission specifically designed to fly much faster and farther than the Voyagers, a dedicated interstellar probe. These future probes would be equipped with instruments far more advanced than the 1970s technology aboard the Voyagers. Such a probe would be a multi-generational legacy, a cathedral of science that would continue sending back data for a century or more. To make these dreams a reality, we must pioneer new ways to travel. These include advanced solar sails, which use the pressure of sunlight itself to push a spacecraft, or laser-powered sails, where a powerful laser from Earth would push a tiny, lightweight probe to a fraction of the speed of light. Other ideas involve advanced nuclear propulsion, far more efficient than the systems that power the Voyagers. Cracking this problem is the key to unlocking the rest of the galaxy for exploration. We have gone from mapping our own planet to mapping the solar system, and now we stand at the shore of the interstellar ocean. The mysteries of rogue planets, the Oort cloud, and the galactic environment are the great challenges for the explorers of the 21st century and beyond. Each step we take into this great unknown teaches us more about the universe, but more importantly, it teaches us about ourselves. Our unyielding desire to see what lies over the next hill, even if that hill is a light year away. Our journey to the edge of the solar system and beyond has been a tale of redefining boundaries. We have learned that there is no single, simple answer. The edge is not a wall or a line, but a series of overlapping frontiers. The twin Voyager spacecraft, our lonely sentinels, will eventually fall silent, but their journey marked the end of the beginning. The great unknown still beckons, vast and full of mysteries, and we, as a species, will continue to answer its call, reaching ever outward into the endless starlit dark. The journey has just begun,